All right, let's talk about building with AI. We've all seen the simple chatbots, right? But today, we're going way beyond that. We're going to dive into how you can build really complex AI systems, systems that can handle tricky multi-step problems. This whole world is called agentic architecture. So here's the big question, right? How do you get an AI to do more than just, answer a single question? I mean, how do you make it think? How do you get it to use tools, to string different skills together, and actually pull off a complex task from start to finish? Well, the answer is something we call an AI agent. And look, an agent isn't just one program. Think of it as a whole system where the LLM, the large language model, is literally in the driver's seat. It's not just talking, it's doing. It's making multiple calls, it's using tools, it's interacting with an environment, it's planning its next move, and this is the key part, it has a degree of autonomy to make its own decisions. Okay, so when you actually go to build one of these systems, you kind of have to pick a side. There are really two big philosophies here. And I love this analogy. Are you going to be an architect, carefully designing a predictable building with a fixed blueprint? Or are you going to be a gardener, cultivating something that can grow and adapt on its own? And this really gets to the heart of it. On one hand, you've got workflows. These are predictable, they're structured. Basically, you, the developer, define every single step of the path. But on the other hand, you have agents. These things are dynamic. The LLM itself decides where to go next, what tools to use. It's the difference between a blueprint and an explorer, really. So first, let's put on our architect hat. If you want predictability and control, workflows are your best friend. We're going to look at 5 essential design patterns. Think of these as the core blueprints you need to build solid, reliable AI systems. First up, the most basic one, prompt chaining. It's exactly what it sounds like. It's a fixed assembly line. The output from step 1 feeds directly into step 2, and so on. Super simple, super predictable. It's perfect for straightforward tasks, like, say, summarize this document, then translate that summary. Okay, next we've got routing. Think of this like a smart switchboard or a traffic cop. The LLM looks at a request and says, aha, I know exactly where this should go. It then sends it to the best tool for the job. If a math question comes in, it routes it to a calculator, not the part of the brain that writes poetry. Makes sense, right? Now, what if you need to speed things up? That's where parallelization comes in. It's all about divide and conquer. A coordinator model takes a huge task, breaks it into a bunch of smaller, independent chunks, and then gets them all done at the same time. You'd use this for sure if you needed to, say, analyze the sentiment of 1,000 product reviews. Why do it one by one when you can do them all at once? All right, things are getting a little more sophisticated now with the orchestrator worker pattern. This is cool. You have one orchestrator LLM that acts like a project manager. It looks at a big, complex goal and dynamically breaks it down into smaller tasks, then doles them out to different worker AIs. It's way more flexible, especially for problems where the steps aren't always the same every time, like planning a vacation, for example. And last but not least, for our architect's toolkit, we have the evaluator optimizer. This is basically your quality control loop. You have one LLM do the work, and then a second LLM, the evaluator, comes in and checks it. If the work isn't good enough, it gets sent back with notes for a revision. This creates this awesome self-correction cycle. And you can imagine this is absolutely crucial for high-stakes stuff where you just can't afford to be wrong. So those 5 patterns, they're fantastic. They give you a ton of power to build systems that are structured and predictable. But what if the path isn't known? What happens when you're facing a problem that's so messy and open-ended that there's no way you could map out every step ahead of time? And that is where we hang up our architect's hard hat and we step into the garden. It's a totally different mindset. We have to stop thinking about rigid blueprints and start thinking about, cultivating something, a dynamic agent that can find its own way. See, unlike those workflows we just talked about, agents are fundamentally open-ended. At their very core is a feedback loop. It's pretty simple, actually. The LLM takes an action, it observes what happens, and it uses that feedback to decide its next action. There's no predefined path here. It's all about adapting to what's happening around it. It's learning and adjusting moment by moment. Now, that kind of freedom is incredibly powerful, but letting an AI just figure things out on its own, that comes with some pretty big risks. If you're going to build an agent, you have to be ready to manage a whole lot of unpredictability. Really, it boils down to 3 main risks. First, the path is unpredictable. the agent might go off and do something you never, ever intended. Second, because the path is unpredictable, the final output is also unpredictable. And third, this one's a biggie, the costs are unpredictable. Imagine an agent getting stuck in a loop, just making API calls over and over. That can get expensive fast. So what do? How do you manage all that chaos? The answer is guardrails. You've got to build in safety systems. These are the rules, the boundaries, the hard limits you put in place to make sure your agent behaves safely, stays consistent, and operates within the boundaries you set. Honestly, they are absolutely essential if you want to use these powerful systems responsibly. And that really brings us back to the big question for you. When you start your next AI project, which path are you going to take? Are you going to be the architect, using predictable workflows to build a super reliable system? Or are you going to be the gardener, cultivating an autonomous agent that can adapt and grow? There's no single right answer, of course. The choice really depends on what you're trying to build.